So if you finish all the implementation about the generic GS solver and the binary GS solver, you can use your form application to quickly test whether it works or not. So suppose right now, I think the current implementation is that we instantiate a GS solver, binary GS solver. So the number of genes is 64. Is a maximization, and this is the optimization objective function evaluation function right here, and we provide the split container, this panel, to display the user's control for our GS solver. So we like to try if the number of gene is large, then what the performance will be for our GS solver. So we change a little bit about this interface. So let me add a numerical up-down right here. And that is for the number of genes. So initially the number may be value 50. Okay, for each increment should be 100, and the maximum value maybe 10,000. Okay, so this is our number. So when user click on this button, okay, int number of genes equal cast nud numerical up-down 1 that value. So we have variable space right here. But the problem is this panel too. If this button is repeatedly created, that means we repeatedly instantiate a new binary GA. Each binary GA will add their control, their monitor here. So before we invoke this constructor, we need to make sure split container 1, panel 2, dot controls, clear all the user interface component. Okay, before that, and then we do the instantiation. All right. So we can test it. So right now the number of genes is 50. Okay. So right now we have a binary GA encoded 1-point card selection right here, 2-point card, n-point card, and crossover rate can be changed. And there is a description about this setting. Okay. So make sure you add the categories and put some description there. And mutation type, okay, gene number based, population based, deterministic, or stochastic. Alright, so right now the number of gene is 50. We reset run 1 iteration. So this is a current based solution. Objective value is 32. Since it's a maximization problem, so the maximum value should be 50, right? So second iteration, as you can see, average is raising up, and even though we did not improve the solver based solution, but it's okay. So another iteration, all right. So this time in iteration 4, the objective value is increased. So we are toward the global best, right? So if you click on run 1 iteration, well, keep pop up, and if I hit the run to end. All right, so we find the global optima 50, right? So all the gene value turn to 1, so that is the global optima. So we know that. And later on, you might try to probably set population size into 5, reset it, and then run to end 2. So similarly, we get the global optima, right? And if I choose different kind of selection, stochastic selection. So right now I really I have implemented the stochastic selection here. Reset, run to end. Okay, so see the differences between stochastic and deterministic selection. In deterministic selection, you will not be able to see the variation of the iteration best because it is hindered by the so far the best if it is a deterministic selection. But if you user chooses stochastic selection, well, in the next iteration, the iteration best might be less than the so far the best. So that is the characteristic of stochastic selection. So which means that in stochastic selection you will see the line iteration best variate, and once this value increase, then the so far the best solution improved in that point. So take a close look at these differences to verify whether you implement stochastic and deterministic solution correctly or not. So make sure you check that. So if user change the solution mode and reset run to end, as you can see, you are not going to see the red line because the red line has been hindered by the red line. Okay, that is the main difference between deterministic selection and the stochastic selection. All right, so probably means if we switch to the switch back to the stochastic selection, reset it, and as you can see, the solution quality is not good enough, right? So based on the same condition, the best solution, the best objective value is not 50, so it is still below the global best, right? But we can change the mutation into population size based, reset it and try to run it again. But it is not guaranteed. But behavior-wise, it will see a little bit difference, right? Okay, so reset, run it, reset, run it, and user can change the setting, reset, run it. Okay, population-based mutation is not good enough, right? Reset, run to end. The global, we know the global best is 50. All right, so if I change it to gene number based, reset, run to end, 50. All right, the solution is not always guaranteed. Anyway, you need to set different kind of parameter and then try to get a result. So probably we will high 100 chromosome and select stochastic. So run it. 37, still not good enough, right? And probably we include maybe 500. Reset, run to end. 37. So the number of the population size does not guarantee that the final solution is better, right? So since we have a friendly user interface, so you should keep changing different kind of value for this parameter to check the evolution progress of your so far the best solution. Okay, and for some other cases, probably we have the dimension of our problem might be large, so maybe 1,000. So for each chromosome, we have 1,000 genes, and population size maybe we switch back to 20. So see, the global optima should be 1,000, right? Reset, normal iteration. So far, oh well, excuse me. I needed to recreate this model. Sorry about that. So recreate this GA model and then reset normal iteration. So right now, 1,000. The number of genes is 1,000. So the current objective is 522. One iteration, second iteration. So the improvement is going on, but well, seems okay. So let us run to end. All right, we did not reach the global optima yet because the global optima should be 1,000. So that will tell you if the dimension is large, then your the performance of your GUI might not be good enough, right? But the problem is that since your problem dimension is large, right? But you simply employ just 10 chromosomes to do the evolution is not enough. So basically, the number of the population size should be consistent with the dimension of your problem. So maybe let us change it into 100. So currently just probably 700, right? So reset run to end. All right, 762. It is still not good enough, right? Well, maybe we increase again, maybe into 300. Reset run to end. 800, right? So again, it does not reach the global optima yet, and it seems that it converges into certain value. This value will not going to be close to global optima. So actually, you still can set different kind of parameter. Maybe set the limitation to 2000. So reset everything and run to end. So that will take up more CPU time to run this evolution. So you kind of change your cursor into hourglass, right? Tells you use a lot, the execution is still going on, and once everything done, set it back to. So does not improve much, right? So we still have quite a distance from the global optima 1000, right? Alright, so the problem might be came out from the number of cuts. Because right now we simply use 1 point cut. How about 2 point cuts, 2 point cuts, and point cut? I didn't implement that. So you should implement that by yourself and to see if this kind of different selection will improve your solution or not. So remember that soft computing has a lot of user specialized parameters, and there is no any certain rule or rigid rule, right? What kind of modification you should done. So basically, what we can do is that if your dimension is large, then we will employ more solution agent to evolve the solution toward the global best. So that is the common sense anyway. But user can always select different kind of operation mode for their evolution. Alright, so that will be all. So you need to deal with your own job assignment problem. Alright? Okay.